Hello everyone, welcome back to SDNBit. In this channel we discuss network automation and programmability concepts. And in today's video we are going to continue to explore network automation possibilities on Arista devices. Now in the previous videos we have talked about general and fundamental concepts of Arista automation. We have tried some very basic scripts on a very basic topology, but in order to really understand and observe the importance and the capabilities of Arista's automation suite, we will have to assemble a better lab environment. And we all know that Arista is the best at data center networking, data center environment. So because of that, I have decided to create a lab of leaf and spine infrastructure and topology. So as you can see on my screen, I have an EVNG lab, and I have assembled already a network design of layer 3 leaf and spine topology. If you want to assemble the same type of network, you can use the official design and deployment guides page on arista.com. So this is the link. I will put it under the video so you can access it sooner. And if you just scroll down and you go to second page, in second page you will find this particular PDF file, layer 3 leaf and spine design and deployment guide. I have already downloaded this file and I have already followed this guide to assemble my topology, as you can see. However, I have completed configuration for left side of this topology. So as you can see, the devices spine 1, leaf 1, and leaf 2 are already configured and, let's say, provisioned as per this guide. However, for demonstration purposes, I would like to configure devices on the right side of the topology in this video, so that in the playlist I would like to include the configuration steps for spine and leaf topology, so you can have an idea on how to construct such infrastructure and how to make use of it. Automation comes very handy, especially in data center infrastructures, because of the complexity and the scalability of the network. So let's get started and configure the right side of our topology as per official Arista Layer 3 leaf and spine deployment guide. Again, the left part is already configured and ready. I have tested it, I have worked on it, and I have disabled all the devices now because unfortunately my laptop is having problems trying to run all of those EOS lab instances at once, because it's not, let's say, the hardware is not good enough, unfortunately. So I've disabled them. I will try to find a workaround, obviously, because I would like to show you entire topology up and running. But for now, let's just focus on the right side and let's just start configuring devices. So I have already put labels of the loopback addresses on top of the device and on the bottom of the leaf devices. So these are the loopback addresses and these are the routing addresses. And I have done this design exactly as per the guide, so I didn't even change much. If you follow the guide, you will see how identical it is to my topology. So let's get started with configuration, finally. I will open up my spine 2, and as you can see, the hostname is localhost, meaning there is no config. I will input default credentials for Arista device, which is admin as a username, and there is no password by default. I will go to the privileged execution mode, and I will drop down to configuration mode. And the first thing, obviously, I will configure is the hostname. I will just follow the same guidelines and standards for hostname naming, and that's it. So the next step would be obviously configuring the users. I have used username Arista, password Arista for devices on the left side. I will do exactly the same here, nothing special. The key, username Arista. So am I missing something? Incomplete command. Why it is incomplete? Maybe I'm doing something wrong. Username, okay, Arista. secret. That must be secret, right? Yeah. Secret also Arista. Nothing to hide here. Okay. So username Arista, secret Arista. We should enable IP routing because it's a layer 3 topology at the end of the day. And obviously, I would like to also add the name servers like I did last time. So let's say 88888. So just open up the guide and keep reading the contents. So I will not obviously read it now because it's a long file for this video to read every single sentence. However, I will just show what we are doing. So I will just drop down to generic configuration. Here you have all the information about the design types, why certain design is better for certain, let's say, infrastructure, and so on. So if you just go down here, you will come to this page where there is this section called configuration examples, right? And if you just follow these example and apply the same configuration, you will have pretty much your lab setup. So I have configured the host name and the IP name server as well. So let's go ahead and configure the domain name, spine2, IP domain name. And in my case, it is going to, okay. So as you can see, this command is deprecated by DNS domain. So we have to use DNS domain command because we are using the latest version of Arista software here, which is EOS 4.31 as of now. And we have to use this command, DNS domain. And if I'm not mistaken, my domain name was dc-lab. dc-lab. Okay, so there we go. I will not configure NTP because I don't need it, it's just a lab, and from what I know, I get the same clock value, 1154, 1254, so okay, we have the UTC time zone. Yeah, that's pretty much good. There's no need to configure an NTP server right now, so we'll just skip this step. And if you go down, you can see that in this deployment guide, there are 4 spine switches deployed, but in my case, there are just 2 spine switches. Again, it is because my laptop is not good enough to handle all these EOS lab instances. If you have better horsepower in your hardware, go ahead, do it. If it's capable, it's worth it. More scalable infrastructure, more things to automate, right? Okay, so as you can see here, we have management interface configuration, loopback interface configuration. We will not need VRFs for now, so I will just go ahead and skip it. I will configure the management, IP addressing, and loopback. So let's start from management interface, interface management 1, IP address 172.19.0, and if you see this table below, it's going to be 11 as per our design. So again, I just follow this IP addressing plan as well. So I'm just going to go ahead and keep following. Done. No shutdown, just in case. Then let's go to the loopback interface. And the loopback IP address is also shown in the same table in the right side. So it's going to be 02/32. So IP address 192.168.02/32. And description will be router ID, right? Good. So we have completed this part. And the next part would be the point-to-point link configuration. As you can see, we have another table of IP addressing. Again, I will just follow the guide and do what is necessary. So I will just go back to my topology because I have already pointed out the specific IP addresses for my interfaces here. So I will just open up this terminal window here, and I will just go ahead and start configuring interfaces. So I will start from interfaces on net 1, which is connected to leaf 1. Right? As you can see in leaf and spine topology, I forgot to say that it's very important and very essential to the fundamentals of this topology. Each spine node has connection to each leaf node. So as you can see, spine 1 has 4 connections to each leaves. Leaf 1, leaf 2, leaf 3, and leaf 4, and the same goes with spine 2, right? So each spine node must have connection to each leaf node in topology, and in the same manner, each leaf node must have a connection to each spine node, which makes this spine and leaf design real, right? So okay, let's go to this interface configuration, and I will just go ahead and configure the IP address, which is 10.10.0.17/30, as you can see right here. So IP configuration will be ignored while interface Ethernet 1 is not a route port, because by default we are running, let's say, switch instance, and to enable routing on the interface level we have to obviously run no switch port command. So I will do it, and I will apply IP addressing configuration again, and there is no wording anymore, as you can see. So if you follow the guide, you will have a generic configuration for point-to-point links, and all I will do is just follow the same things here and apply to my own interface. So let's just go ahead and do it, right? So let's assume this is our interface Ethernet 1. Description is going to be point-to-point link to leaf 1. Now this is the example for spine 1, but yeah, based on that, we'll just do the same for spine 2, obviously. Now, the speed configuration obviously is not necessary in lab conditions because we don't really have the bandwidth, the physical connectivity present, but just for the sake of configuration completion, let's say, or compliance, let's just run it. There's nothing really. We can use this data to fetch from automation devices so that we can have more outputs, more data to work with, let's say. So there is, yeah, it's not going to hurt if you add this additional commands here. It's not going to hurt, definitely. And so ARP timeout 900 command, it's a little different in this version. So if you run ARP time and if you press tab, there's nothing coming afterwards. So if you hit the question mark, you will see there is aging option. So after certain software upgrades, they decided to change this command syntax. So now it's ARP aging and then timeout, and then you put the seconds, 900 seconds in this case. So the configuration for interface Ethernet 1 has been completed. Let's say show active and see. As you can see, this is our config. Good. Let's go ahead and do exactly the same thing for another interfaces, right? We have 3 more interfaces to configure for each leaf node. Let's go ahead and do it. So the description is going to be, actually, I can just find the same commands and just change the IP addressing. In this case, their IP will be 21. So back here, spine 2, 21, right, /30. Of course, I forgot no switch port. Again, no speed. The same, the logging, and ARP aging as well must be present for compliance, and I think that's pretty much it. Show active. Yeah, I haven't missed anything. The same goes for interface Ethernet 3, obviously. Let's start with description. Leaf 3. No switch ports. IP addressing is going to be 25, if I'm not mistaken. 25 exactly. That is right. That is right. So 25. The speed, logging, ARP aging, show active. Good. And the last interface on spine 4, point-to-point link. Obviously, the link to leaf 4 device. IP addressing 29, but before no switch ports. Good. Speed, forced, logging, and ARP aging. Show active. Good. We are done with configuration of interfaces now, and if we scroll down, we are going to the section called leaf switches, meaning for now the point-to-point links are, we're done with point-to-point links for the spine device, right? So let's just save this config, and let's go ahead and actually take a look at configuration, interface configurations of leaf devices. So if I go back to my topology, as you can see. In this case, we have two configurations to spine two interfaces, obviously. So I will go ahead configure all of them anyway, because that's what we need to do, right? So let's start with leaf 3. We have to start with basic configuration. So admin enable conf hostname leaf-1 IP routing username Arista secret Arista. Good. What else? So the DNS domain dc-lab and IP name server 888 for DNS resolutions. What else? Am I missing something? I will just check the guide real quick. And yeah, it looks like there's nothing else for now. Let's do exactly the same for leaf 4 right now. So we have the hostname and basic generic config completed. Enable conf hostname leaf-3 username Arista secret Arista. Obviously the IP routing must be enabled, right? And what else? DNS domain dc lab IP name server 888, right? Okay, no need for NTP config here as well. Okay, I have made a mistake for some stupid reason. I put completely wrong host names. Let's just fix that. This is leaf 3 and this is leaf 4. I must have got confused because of the deployment guide. Okay, we'll fix the host names. Now that looks better. Leaf 3, leaf 4, generic config completed. So let's just go ahead and see what we have for interfaces here. So as you can see, there are same kind of, let's say, recommended commands for leaf and spine design configuration in data centers. Again, we might not need to put this MTU, for example, or enable logging, but just for the sake of compliance to the guide, I will just go ahead and do it, right? So first we can just, like, instead of configuring each interface one by one, we can just configure every similar command for each interface under the range command, so we don't have to do it one by one. As you can see, leaf 3 has connection to spine 1 and spine 2, and there are other connections which we will discuss later. So for now, we just need to configure two interfaces, Ethernet 1, which looks towards spine 1, and Ethernet 2, which looks towards spine 2, obviously. So let's go ahead and do it. So let's start with generic configuration application. Leaf 3, I will say interface, Ethernet, so you can say show IP interface brief, show interface description, sorry, that would make more sense. As you can see, there's nothing configured yet. And I have also forgotten configuring the loopback and management, so let's go ahead and do it before actually, so we don't really get confused afterwards. IP address will be, so if we just go back to this guide, the leaf, so for me spine 2 was this 11. If I'm not mistaken, for leaf 1 my configuration was not done. 12. So 12 was for leaf 1, 13 was for leaf 2, so 14 and 15 will be assigned in this case because I don't have 4 spine devices, I just had different mind in configuring. So 14 /24, there you go, interface loopback 0, IP address 192.168.0.5, because there are 2, 3, 4, 5, yes, that's right, /32. Description, router ID. The same goes for leaf 4. We just do it here. Interface management 1, IP address 172.19.0.15/24. That's right. And interface loopback 0, IP address 192.168.0.6/32. Description, again, router ID. Good. So now we can go ahead and apply interface, point-to-point interface generic configuration. So if I open the template here, I will obviously take interface Ethernet 2 and 1 in this case. So leaf 3, interface Ethernet 1-2. Okay, so this is how we define range in Arista EOS. Instead of the range keyword, we just have to put dash and specify the range. So speed forced 100G full, although not necessary, but let's make things interesting and spicy. MTU, logging event, link status, no switch ports, ARP, aging, timeout 900 seconds. Good. Now let's go ahead with IP addressing one by one. Interface Ethernet 1 will have description of point-to-point link to spine, or let's just put it spine 1, that's better. And the IP address will be 10, 10, 0, go back to topology, 10 and 26. Good. 10/30. Good. Interface Ethernet 2. Same description almost, but the spine 2. And IP address 26.26. Good. The same will be done for leaf 4. So let's just open up the leaf 4. Good. Interface Ethernet 1, 2. Speed forced 100G full. MTU 9214. Logging event. Link status. No switch port. ARP aging. Timeout 900. Good. Interface E1. What are the IP addressing? 10.14 and .30, right? .14 and .30. So description to spine 1, IP address 10, 10, 0. Again, just to specify 14 and 30. 14. Interface Ethernet 2. Description to spine 2. Is that correct? It is correct. And .30 in this particular case. Good. So now we're done with interface configurations for point-to-point links. And let's see what happens now. Let's check LLDP neighbors. As you can see, we can detect our neighbors via LLDP already. I mean, even before config, you could do that, obviously. So because LLDP is enabled by default. Spine 2 on the interface Ethernet 2, and leaf 4 on interfaces 3 and 4, which will be explained later why we have this interconnection. Now let's just check the guide and make sure we have completed with interface configurations. And if you just scroll down, you'll have a new section called base routing and BGP configuration. So you can read the details here, why we need BGP and why not other routing protocol on layer 3, such as IGPs. And you will see that the real reason is because in data centers, to handle the amount of routes learned from all over the world, can be handled by BGP better, because BGP is designed to work with huge routing tables And to accommodate it, and for obviously other benefits like policy implementation, BGP is preferred and recommended protocol for routing in this kind of topologies. Let's put it this way. And here we have the configuration template for our devices, right? So I've already configured IP routing, and let's open up the spine too. But before, let me just save what we've done on leaf switches as well. And I will open the spine 2 configuration, and I will try to see what is going to be done now. So I've already done the IP routing, and we have to now establish BGP sessions, obviously. As you can see on the topology, we have 2 autonomous systems. So spine devices are within the autonomous system 65010, whereas the leaf devices are, and the servers obviously are in the autonomous system of 65020, right? So between those devices, we'll have eBGP, because those are different autonomous systems, but within these autonomous system, all the interconnections will be configured by iBGP if necessary, because they are in the same autonomous system. So let's just go ahead and configure this. Router BGP 65010. Router ID is going to be our loopback IP address, so I will just go ahead and specify it directly. BGP log neighbor changes. Distance BGP. I'm just following the guide. If you wonder what this command means, distance BGP, just read the guide and you'll understand. It's not necessary to do it here as well, because it's a lab environment, but again, I just want to make things more interesting, because we will need different types of data during automation. Maximum pass 4 and ECMP 64. Now we don't have to put 64 because we don't really have that much paths in our topology, so I would just put 4 in our case, because we have 4 links to each leaf device. So 1, 2, 3, 4, no need to put 64, but again, like, if you want, you can do it. It doesn't mean much. I just want to make it identical to my left side, so that's what I did on left side to avoid any other confusion. So spine 2, right? Right. Or actually, let's make it 64. Why not? Does it matter? No, it's just lab. Who cares? So yeah. Now we have here something called the peer groups. Those things are just to facilitate the categorization of our BGP neighbors. So we could just skip it and run this simplified configuration without the peer groups usage, and we'll just specify them one by one and nothing else. But since I did this part on the left side of the topology, I would just go ahead and do the same. And as you can see, I will just have to put these names for the peer group. We don't have to put dash because it's deprecated, but it's essentially the same thing without dash. And our neighbors, our leaf neighbors, are in different autonomous system. Let's specify that by remote AS command. Obviously, maximum routes 1200. There is absolutely no need to put this command here, because again, we don't run actual DC infrastructure, but why not, right? Why not? And then we specify neighbors one by one. So neighbor 10.10.02, but this is for spine 1, so I will go here and I will use these commands. This IP address is obviously to specify our neighbors. Neighbors 10.10.0.18. Peer group, we are adding this to peer group. eBGP leaf to peer. And then we have 10.10.10.0.22 for the leaf 2, and of course 26 and 30, right? 26 and 30. That should be it. Go back to guide. And we advertise our loopback network, obviously. So let me just put our loopback address here, which is in our case is 2, because we're running it on spine. Done. So we can skip this part and we can go to configuration of leaf switches. And let me just see how it looks. Show active. Looks about right. Let me just compare just to make sure we don't have any misconfigurations or typos. That's right. Okay, I'm gonna quit BGP config and save it. And let's open up the leaf devices, and they're pretty much the same here by checking out this generic configuration. Again, we have already enabled IP routing, so let's just go down and instantiate BGP autonomous system 65020 in this case. Again, router ID will be our loopback address, which is 05 in our case. This is just a coincidence. It shouldn't be 5 if you have 4 spine devices. BGP lock neighbor changes. Distance command again. Yes. Maximum pass 4, ECMP 4 in the leaf case. We can put also 2 because we just have 2 links. I mean, but yeah, but there's no need to actually care much about this. And I think here I can just go ahead and copy this part because I don't really want to waste much time. And just copy it here, I guess. There's nothing different. And then the neighbors of our leaf. Now, the 4 spine devices, but in our case we have just 2 spine devices, so we'll just put obviously this neighbor 10.10.09 and 10.10.025, right? So neighbor 10.10.09 peer group spine. Let's just copy this. Paste this one and 25. Good. And we have to advertise our loopback network and also the connected routes. Now the connected routes are distributed because we have the servers connected to us, to the leaf switches in this case. So this routes will also be advertised to the spine devices and other leaf devices as well, obviously. So we can quit this, we don't need this anymore. And redistribute connected complete. Now let's see how it looks. That looks pretty good. Now we can just, I guess, copy this part because it's the same and apply for leaf 4. So router, BGP, the same goes here, nothing special apart from IP addressing, obviously. Router ID 192.168.0.6 in this case, and network 192.168.0.6 should be advertised as well. Redistribute connected routes, apply generic config, and set the neighbor configuration by changing only IP addresses of neighbors. So for leaf 4, we have the .13 and .29. .13 and .29. .13 and .29, right? Nothing special in this case. Let's go ahead and see what else we have in guide. So in guide we have this route advertising session, and here we could configure the prefix lists to filter out specific networks for reachability. However, there is no need to do this because, again, we don't really care about security concerns in the lab environment. And as you can see, it's mentioned even here, although not mandatory, using a route map provides a level of protection in the network. Without route map, random networks could be created at the leaf, which would automatically be added to the data center's route table. We don't care about that because we run even glab environment. So I will just go ahead and skip. So if you skip it, you will see that we are getting into the MLAG configuration section. And before getting there, let's just verify that everything is okay with our topology. And let me just actually see what's going on. So I will just open up my devices and let's check the routing table and BGP output to make sure everything is good. So let's start from the spine device. So let's go back and let's start with, again, LLDP. So we can see the neighbors, right? We can see leaf 3 and leaf 4 connected on Ethernet interfaces 3 and 4, which makes perfect sense. Let's check the descriptions of interfaces and their status. So it doesn't look very good. That looks better. Loopback interface and our point-to-point links, as you can see. So all of them are up and running and descriptions are set correctly. And let's check our IP addressing. Show IP interface brief command. Now there is one thing that I might have missed. For some reason the MTU is not 9214, maybe because I forgot. Oh no, it's because it's spine, we don't need it here, that's right. Nothing, everything is correct. So we have these IP addresses. Let's just go to topology and just verify if we have the correct IP addressing here because it's important. So 17, 21, 25, 29/30, everything is done correctly. That is good. Show IP route command to see the routing. So as you can see, we have obviously a bunch of connected routes, our local interfaces, directly connected routes. We have our management interface and loopback interface. And then we have other routes learned via eBGP, right? So we can learn about 10.10.0/08/30. And let's see where is this network located. It is this one, right? 10.10.12, which has to be this one. And obviously the loopback addresses of our leaf switches being advertised via BGP and learned for spine 2. So let's try to ping some of these addresses and let's see if we're lucky with it. So let's start with loopback addresses 05, good, 6, good. And what about these addresses right here? So 10.10.08, we learned it from 26, so we should be able to ping this interface, which is 10.10.10.10, sorry. Let me just open this up. I should be able to ping 10.10.0.10, good. Let's check the BGP summary and see what is going on. We can see that we have established sessions already and 4 NORIs are being received. Now, these sessions are not established because devices are down. Once I power on the sleeve switches right here, the BGP session should go up. We'll test it later. For now, we don't look at the left part of topology. Let's just check the same stuff on leaf 3 and leaf 4 real quick. Show LLDP neighbors, looks good. Show IP route. Again, BGP learned everything. Show BGP summary. Established, as you can see. Yeah, we just have one session because the other spine is down, which makes perfect sense. And the leaf 4, real quick, also show BGP summary. I will just extend this window as well. Good. Everything seems to operate correctly. Now we can save our config here, and we can go ahead to MLAG configuration. Right, so MLAG config. So yeah, we have already generated configuration for leaf 1 and leaf 2. I have followed it to configure them. Now we'll do pretty much the same thing for leaf 3 and leaf 4 to configure MLAG. Let's do it. So this is my leaf 3 device, and let's actually just see if we can see the interfaces. Show interface description. So interface Ethernet 3 and 4 are connected for MLAG purposes here, and it should be the same configuration. I'm just checking what I might have missed to make sure if everything is okay. Yeah, so here in the guide, they are using interface Ethernet 47 and 48, but we don't have so many interfaces in our VEOS lab instance, so I will just use 3 and 4, obviously. And let's go ahead and configure them real quick. So conf, right? Now we can basically say interface Ethernet 3, 4, and configure the same things. For example, MTU command is the same for both. I can see no logging event link status command issued. Let's do that as well. To the no logging level, we don't have this command. What do you want? No logging event, sorry, event link status. That's right, switch port mode trunk. Is it for both of them though? It should be for both of them, but for some reason it's not. Interesting. Why not for both of them? Maybe it's just a typo, or maybe I'm missing something. Yeah, I feel like both of them should have it. Like, even though we are including it into the port channel, if one of them goes down, port channel should operate based on the trunk configuration as well. And if Ethernet interface 48 goes down with this configuration on it, how the hell 47 is going to advertise VLANs? So I think it's a typo, maybe it's just they missed it somehow. So I will just configure it for both of them anyways. Trunk allowed VLANs. 100, 200, and 4094. Now these LANs are, so 100 and 200 are for our servers, connected to leaf switches obviously, and this LAN is special LAN. We use it for MLAG configuration. If you want to know what exactly it does, just go ahead and read MLAG configuration guide on Arista's official website. Yeah. So no SNMP, trap, link change, or link status, whatever, it's deprecated probably. Channel group, one mode active, we're enabling port channel. OACP configuration, port priority, 1600. Storm control is not supported on the VEOS lab because it's a virtual instance. And it's not necessary anyway. No shutdown, no needed because the interfaces are up and running anyways. So I think that's pretty much it. And now we just have to set correct descriptions for them. So for this interface, we have description layer 2 trunk. I think we have exactly the same descriptions even. So yeah, because we're connecting to each device, same device. So let me just go ahead and do it for both of them. I could just copy everything. I mean, yeah, but that's fine. That's fine. Trunk link to leaf 4, right? Good. Layer 2 trunk link to leaf 4. Now just show active. Let's just check real quick. MTU, no logging. Switchboard trunk allowed 1, yes. Mode trunk, no SNMP. OSP port priority. Okay, good, very good. Exit. And the same obviously goes for leaf 4 devices. Just let me see, is there anything? Yeah, but the port priority will be different because we want the other port to be more powerful. Just checking if there's anything different that might confuse us, but there is not. So let's just go ahead and do the same thing. So specify the range. Description is going to be to leaf 3, obviously. And everything else can be copied up until this part. LACP port priority will be 32,000. And that should be pretty much it. Good. Show active. Let's just compare real quick. Looks good. So this is the MLAG configuration, but we're not done yet. We have the VLAN configuration, obviously, and the MLAG configuration itself for the protocol. Let's open up the leaf 3, right? And I will just check my leaf 1 and leaf 2 config. Good. So first we configure the 4094. Can we copy and paste without IP addressing? We can, but let's just say MTU9214. IP address, we can put another IP address. We can put 10.101/30 for this site. ARP aging timeout. I'm putting a different IP address because on the left side of the topology, I have the same IP addresses, and I would not like to have identical IPs on between both leaves. So yeah, that's why. You are free to do else if you wish to. The VLAN configuration is done. So MAC address table aging time, we're increasing it to 1200 seconds, although not necessary, but let's just follow the config. And there is IP virtual router MAC address. I have set this command on the other leaves as well. And I'm not sure if we should do exactly the same thing, because it wouldn't make sense to have identical MAC addresses, virtual MAC addresses on both sides. So let's just skip this command here and let's see how it will end up in our case. We go to MLAG configuration, domain ID, MLAG peer, local interface, WAN 4094, peer address, peer will be 10.102/ there's no slash, and peer link will be port channel, which we haven't configured yet. We will delay 60 seconds. Why we forgot it? Because I forgot it. I shouldn't have, but I did. Anyways, so let's also do it for leaf 4 before actually going to port channel config. So let me just open up the leaf 3 just to make sure we're on the same page. Okay, looks good. I'll just follow this here. So interface WAN 494, description, copy this, paste over here, MTU9214, IP address 10.102/30, ARP aging timeout 900 seconds, the MAC address table aging time, MAC address, oh no, we should quit one config, aging time 1200 seconds. We're skipping the virtual router MAC address part for now. I'm wondering if it's gonna set a virtual MAC address by default. So MLAG configuration, domain ID must be same, MLAG peer, local interface WAN 494, peer address 10.101, peer link, port channel 1, reload delay 60. Done. Now, let's go ahead and finish this MLAG configuration by enabling port channel. So this is interesting, right? It's in the guide, they specify port channel name as 48, but for some reason, they specify port channel 1 here, which again shows there are some kind of typos in this guide, so be careful of that when following. Just question everything you do and make sure it makes sense. Yeah. So leaf 3, right? Now, can we copy and paste it? Because I don't really see something that different here. Another thing is, like, looks like this trunk config should be just in port channel, not even in both of them, but I don't think it will hurt. So let's just go ahead and copy and paste this, I guess. Now, description is going to be different, obviously. In our case, if we're in leaf 3, it's going to be interface port channel 1 to leaf 4, and everything else will be copied and pasted. And the same applies to this part. Exits, interface port channel 1, description, leaf 3, show active. I'll just copy it from here. Good. Good. So MLAG configuration should be done as well. I don't see anything else here. Maybe we could miss something. And IBGP configuration for the MLAG. Yes, we have to also configure IBGP so they can exchange routes between each other. So let's just go ahead and do it. From what I understand, there shouldn't be much config, especially considering the fact that we've done some of them. Exit, router, BGP 65020, neighbor 10.1.0.2, remote AS 65020, meaning this is IBGP. The same neighbor, next hop self. Now, if you want to know why we use next hop self and allow us in commands, just again read the design. It will make sense. And maximum routes 1200, although not necessary, but let's just do it. I don't think it will affect our device performance in any way, shape, or form. And the same goes here. Let's do it manually. So router BGP 65020, neighbor 10.1.0.1, remote AS, the same AS, next hop self, allow as in 1, and maximum routes. Now, it might end up with a lot of errors for me, but that's the point, right? I'm learning and we're learning together the Arista's leaf and spine implementation. Okay, so this is done, and let's check the MLAG now, and let's see what kind of output we get from the operational commands. So let's start with checking the IP addressing. We can all instantly see that our VLAN is down, which shouldn't be, and because of that, most probably we'll have MLAG inactive. So if I say show MLAG, we can see that yes, it's an inactive state. Negotiation status is stuck and connected. However, peer link status is up, so we will have to troubleshoot that first. But I would also like to understand how about our, not the best form of output. Okay, now how about our port channel config? That's up. That's right, because port channel doesn't have any IP address. And routing, there's nothing about IBGP yet. And the reason for that is because the VLAN for 4094 is down, basically. So now let's try to understand. I will just really quick check my leaf1 config to see what might cause this issue. And still checking. The trunk group command, exactly. So they missed to add one command here. Maybe it's just deprecated yeah, maybe the reason why the guide is deprecated and these new devices need to specifically indicate this command. So there is this command called trunk group, and we have to specify it under the VLAN config, the VLAN 1494 config. However, for some reason, I think we already did it another way, didn't we? No, we didn't. Yeah, that's the point. So if you go to config, if you go to interface VLAN 1494, my device is stuck for some reason. What happened? Let's go to leaf 4. Leaf 4 is also stuck. Seems like I'm having some issues with my CPU. Hello again, guys. Sorry about that. So we're back now. Unfortunately, my CPU couldn't handle all these workloads and decided to just shut down my EOS lab instances. And I had to actually power off my virtual machine and power on again. And some configurations have been erased because I haven't saved them on Leaf devices, Spine devices. Spine device didn't have any configuration loss. So I had to reconfigure them real quick, and I've made some changes during reconfiguration, nothing major, rather minor. And yeah, so now we can proceed from where we left off. Last time we checked the interfaces, the IP interfaces, we detected that our VLAN is down, and I wanted to inform you that the reason for this is because there's one missing command under VLAN configuration which has not been indicated on the design and deployment guide which we are following. Right? So this command is basically something we call a trunk group command. And to enable it, we have to go to VLAN configuration. So VLAN configuration. And we have to specify trunk group and the name of our MLAG domain, which is MLAG here. And if we do it here as well on the other side, we should be able to see VLAN interface coming up instantly. So let me even, there's no need, trunk group, MLAG here. Now if we run this command again, sorry, not this one, yes. Now the VLAN interface has come up, so let's just verify it in this part as well. Good. Can we see the BGP sessions being established? Let me just extend this window for clear output view. Show BGP summary. It's still active, it's not established yet because unfortunately when the devices went down, I couldn't save configuration before, so I have to reconfigure the BGP configuration as well, but for now, at least, just to make sure, some details. Okay, so let me just go back to this BGP config real quick, which was somewhere here, yes. And let me configure it real quick. So this is spine 1. No, we need it for the leaf, not spine. Where is it? We need IBGP configuration. Yeah, it's right here. So router BGP 65020. Sorry about that. 020. Neighbor, in our case, will be 10102. Remote AS 65020. Neighbor 10102. 02. I shouldn't. Yeah, I just got distracted by simple thing. Allow as between 1 and maximum routes. Maximum routes 12,000. Okay, now leaf 4. Obviously, the same kind of config. So I'll just copy and paste. By changing the IP address here to 1 and then running this command self allows in 1 maximum routes routes 12,000 and show BGP summary. Now it's established. Okay, good. And this side should be the same. It is the same. Now we can save the config after completing finally the MLAG configuration. And now we can go ahead and check MLAG status. Show MLAG. The state is disabled. Why is that? Should it be disabled? Peer address, WAN. It is disabled. It shouldn't be, or should it be? Dual primary detection, interface or disabled, false. Show run section MLAG. Show run section MLAG. Maybe I forgot something. Let's troubleshoot it actually. MLAG state disabled Arista. Disabled. MLAG configuration changes, the TCP connection breaks, the peer link or local interface goes down, the switch doesn't receive response to keep a live message from its peer within a specified period. So this is one of the reasons. Now let's try to troubleshoot it, I guess. So the first reason might be MLAG configuration changes. I don't think we have any MLAG configuration change. It might affect. Let me just check the routing also. Can I ping my peer? I can. And show interfaces description. Show IP interface brief. Let's check the show MLAG again. Disabled. Ah, it's the oh no, it's the, I thought it's negotiation status, but no, it's MLAG status disabled. Interesting. Domain ID. Why there is no domain ID specified? That's weird. Shouldn't there be a domain ID? Ah, there we go. In this case, we can see domain ID, but in this case, I probably forgot it. So show run interface, WAN 494. Somewhere we have to specify domain ID, right? Show run. Let's just put include MLAG peer. Let's see how many cases. Domain ID. Where is this command? Domain ID. I think it should be under WAN, if I'm not mistaken. That's not under WAN. Then it should be under the port channel, perhaps. Port channel 100. Show run interface, port channel 100. MLAG peer. So we found one instance. Show run section MLAG. What is wrong here? Show run in section MLAG. Okay, under MLAG config, that's my problem. That is my problem. Just go to MLAG configuration and add this command here. So now it should go up. Show MLAG. It is better than disabled, but it's still inactive. Maybe we should give it some time, but I don't think so. That doesn't make sense. It's disabled in this part still. This is interesting. And in this side we cannot see the peer link. So perhaps my show run section MLAG peer link. Okay, I'm missing peer link configuration here. Peer link port channel 100, and now it should be better. Still, I mean, it's better, but we still have issues with state being inactive, so let's go here and search for inactive. Right, so configuring downstream switcher route connected to MLAG peers to negotiate the lag using OHTTP rather than configuring static lags. Using lags negotiated by OSP can help avoid problems caused by miscabling because OSP PDUs include a system ID and OSP key which identifies the switch and the lag it belongs to. If MLAG miscabling happens using OSP lag, some ports will be inactive. Miscabling, okay. from bridging traffic events. Similarly, when MLAG says primary on one switch and inactive on another, the peer switches are acting as two independent layer 2 switches. So this is interesting. Let me run this command again. It's inactive on both of them, and I don't think it should be. Although the peer link status and local interface status is up, negotiation status connect. Maybe it's due to OACP. Let's check the OACP configuration. Show OACP peer, maybe bundled, and here show OACP peer. Interestingly, the port priority is the same for both of them. Maybe that's the reason why. Because I haven't. It looks like I forgot to. Maybe that's the problem. Okay, so interface Ethernet 3, 4. Let's change the port priority to 30. I forgot to hit enter. 32,000. And did it help? Not really. And here, not really, nothing. What else? What else we can do here? Towards inactive interfaces. What does it mean, inactive interface? What is precisely wrong with it? Verify the peer switch connection. It should be active with this, right? MLAG ports should be here, MLAG ports. There is no inactive MLAG port, right? Active full. Is it active full? It's not active full as well. It's not inactive and active. That's weird. What else we have here? Show MLAG interfaces. Show MLAG interfaces detail. Let's run one of these commands. Show MLAG interfaces detail. No MLAG ports configured. What does it mean? It means there's something wrong with our configuration. That is weird. Verify the MLAG port channel. Show port channel 100. We can verify. Show interface port channel 100. I'm looking at spine, sorry. Leaf. Show interface port channel 100. So it's up. Where to trunk link to leaf 4. The speed is 2. The bandwidth is 2 gigabytes, meaning both interfaces have been successfully aggregated under port channel. The status is up. Show IP interface brief. Weirdly enough, show interface description. This is interesting. Okay, what else we can do here? That's weird. Show run includes MLAG. That makes sense. Just entire running config maybe. And the leaf 4 for comparison reasons. Show run. Right. So this part is the same. Maybe it's because virtual MAC address. We didn't configure virtual MAC address. Maybe that is the reason why. So, and here it looks fine. I don't see a particular problem in this part. So let's see the physical interfaces. I didn't put trunk configuration after reconfiguring them here, so maybe that is the problem. But I don't think so. It shouldn't do anything with it. So now SMP trap. That is and port channel config. Looks like everything is fine. I don't see any particular problem here. Show spanning tree. Show spanning tree. Anything weird? Not necessarily, no. I don't see anything weird here. No. It looks good. And BGP sessions are also established. That is... We can even ping each other, but MLAG is inactive. So what is the problem with MLAG? Right. Let's go to the first one. Needs state inactive. Let me get leaf 4 here and examine the output again. So just clear everything. Show MLAG again. I can see that the main ID, the VLAN, the peer IP, the port channel, that is right. However, there's nothing about negotiation status here. So maybe it's because of the system ID, because I don't really think, yeah, I think this is probably the reason why it's happening. So let's go ahead and run this command, and let's change it a little bit. So I will change the last octet to avoid confusion with other leaves. Let's change it to 89 or 88 even, and the same goes here. If I'm not mistaken, they must have same MAC addresses. That is right. 88. Show MLAG. No. No. So the system ID has nothing to do with it. That's weird. This is different than what I expected. Can we restart MLAG somehow? MLAG configuration. What we have here. The way after rebooting to all non-peer link ports. What if we shut down the VLAN and what if we shut down the feature and we will get this message, okay, and at this point the status should be show MLAG. Still nothing changed really. Okay, so let's now shut down it and we should get it back. There's no logs. No, really nothing. What about interface port channel 100 shut down? How about now? Yeah, we can see that the peer link went down, but that's the only thing we can see. And if we re-enable it, it went up, but it's still inactive. Some kind of logs are observed. BGP logs, sent to neighbor. Okay, nothing special, just some packet loss probably. That's interesting. So, show MLAG interfaces. Let's run this again. Show MLAG interfaces. No MLAG ports configured. Let's try to search this one right here. Arista. Okay. Seems like there is the question already asked. And looks like you have the MLAG pair configured properly, but no MLAG ports can be connecting servers or switches. Connecting servers or switches. Configure a pair of MLAG ports on a pair of interfaces. You will see the output of show populated. By the way, for testing web purposes, having a mixed pair of switches, different ASCII families is fine, but this is not recommended configuration for deployment. There's a difference in forwarding pipeline. Okay, so that is the reason. I understand. So it's because I didn't configure the VLAN interfaces. That is a problem, right? So let me just go ahead and do that, and let's see if we can see any progress. So I will just open up the leaf 3 here, and let's configure this 100. So I'm just finishing up the guide. This is the last section of the guide, and the last section of the guide is the server connectivity, VLANs and gateways configuration. Unfortunately, we cannot really do the dual home configuration. Yeah, I drew it here, but although I drew it here, it's not going to work because in this VOS lab instances, the virtual IP is not supported, and we need virtual IP address to be able to complete the MLAG configuration, but unfortunately, again, it's just not supported. So wait, let's just go ahead and do it, but yeah, it shouldn't really work properly, but why not? 100. Let's just copy and paste these parts. Actually, is there anything different? I don't think there is. The gateways shouldn't be the same, the gateways, but okay, whatever. Let's actually do it by ourselves, because I don't really think we have to. So 230, and the gateways should be same. Okay, let's just copy and paste it. ARP aging timeout command. ARP aging timeout 900 interface 100 ARP aging timeout 900. Okay, and let's configure the interface 5 in our case. Switch port access WAN 100. Storm control is not supported. No SNMP trap link change. Spanning tree port fast, and spanning tree BPDU guard enable, right? Right, so, and we have to do it on leaf 4 as well, so we can just copy and paste this part. ARP aging timeout 900, interface 100, the same command. Interface Ethernet 5, switch port access let's say 200, 100 on the leaf 3, 200 on the leaf 4, because that's what we can do instead. And yeah, the same generic commands should be applied here. Storm control is not supported. Spanning tree port fast. Ignore the warning because we're indeed connecting to server. And spanning tree BPDU guard enable. Now let's check MLAG now. It's still inactive. Why? Maybe it's because we have to enable the Linux server here, so then it can detect it and then it can actually activate MLAG. But even if I do enable this server, it has nothing in it, so there's no configuration whatsoever and nothing's going to work out. But I guess that's it. We completed the guide. If you actually check yourself, you will see this was the last section, and we can close it now. So yeah, I will just assume this is the problem. We have to have enabled device already configured, so this MLAG should be activated. But if I say show MLAG interfaces, there's still this command no MLAG ports configured, meaning it doesn't really work if there is no device needing MLAG feature, which is very smart actually. So in this case, I do believe there's nothing else to do, and we have now full network topology which operates properly as a leaf and spine topology. And in the next video, we will use this topology to test different network automation cases, primarily using PyEAPI library for Arista. We'll run some scripts on Python, and we will actually use the spine switches or any other switch as a network automation controller, meaning we will use the bash shell of an Arista switch to execute the Python scripts and to work on anything we need, right? So thank you for watching this video. Unfortunately, because it was the first time for me with Arista's spine and leaf configuration, I had also a lot of questions in my mind, but I will make sure that I complete this MLAG configuration, and in the next video I can verify it for you. And the primary cause of this playlist in this channel is exploring network automation and programmability, not necessarily the actual data center infrastructure configuration. So, but still, this is what you also can create in your lab environment. So you have a handful of devices to be able to work with their automation. You need some data, you need different sort of data, you need different sort of configs, and afterwards you can check how you can automate certain workflows or collecting certain operational data. So this is prerequisite. This is a huge prerequisite that will make your automation journey much more interesting. So thank you for watching this video again. See you in the next video. We'll keep discussing the automation possibilities in Arista ecosystem. Leave comments below if you have any questions, and see you in the next video. Thank you very much.